This is the last problem in the assignment. So let us take this circuit outside and see how can we calculate the initial conditions. We need to calculate I0 and V of 0. So let us first draw the circuit before you change the switch. It is clear that according to this circuit that the switch was on, was connected, and then you disconnected. So let us draw the circuit here. So the switch was connected. Okay, so this is how the circuit looked like. This one was connected like this. Okay. Also, the inductor is short circuit. The inductor was short circuit here. This is in case of DC, usually the inductor is short circuit. The capacitor is open circuit, so let us take this out. And we know, remember the position of the capacitor. So actually, this is the voltage across the capacitor here. The voltage across the capacitor is between these 2 points, which is the voltage across the 1 ohm. So now let's calculate I of 0 and V of 0. I of 0 according to this. So I of 0 is this current here. I equal what? I equal R here equal 5, I believe. R equal 5. If I remember it right. Let's check. R equal 5, yes. Okay, so the current I equal what? Equal 24 volts. You have this 24 moving like this. So it will be 24 divided by R plus 1, which is 6. That's 4 ampere. So the initial current is 4 ampere. And the initial voltage is the voltage across the 1 ohm. So it is the voltage, the current time resistance. Current is 4. 4 times 1 will be 4 volt. So it is this current here. The current is 1 ampere, is 4 ampere. The current is 4 ampere. 4 times 1 is 4 volt. So this is the initial current and initial voltage. Now let's calculate V dot and I dot. So I dot and V dot at t equals 0. Okay, again, I dot is VL divided by L, and V dot is IC divided by C. So let us look at the circuit after you change the switch. Here is the circuit. Okay. When you change the switch, this means the switch is open. The switch is open now. When it is open, this 1 ohm is not connected to the circuit. So you can remove it like this. This is how the circuit look like when you turn off the switch. So we draw the circuit now. Let us put the data that we have. What do we have? We have the current is 4 ampere. So this current is 4 ampere. Oh, first. Let me write it here. I equal 4. So this current is 4 ampere. And the voltage equal 4 volt. As I said, this one will not change suddenly. So the voltage is 4. The current is 4. Okay, so we have all the data now. So let us see what's IC and VL. IC is this current. IC is this current. This is IC. It's very clear. This is IC. So IC is what? Is 4 ampere, of course. Because the current is 4 ampere. The current is 4 ampere. So it will remain 4 ampere. 4 divided by C, which is 0.25. So it's 0.25 farad. 4 divided by quarter is 16. Okay, so this is V dot. Why? Again, 4 ampere will continue like this. This is the current, is 4 ampere. So the current in the capacitor is also 4 ampere. Makes sense. What about the voltage across the inductor, VL? I want to find this VL. I don't know VL, of course. So I have to, because there's nothing here connected to directly parallel or anything, like in the previous example. So VL, we need to use Kirchhoff voltage law. So here we have this 24 volt. This is 24 volt. R is 5, okay, and the current is 4. So the voltage here is 20 volt. R time what? R time 4, the current time resistance. 4 time R is 5, will be 20. So this is positive here, negative here. And the voltage here is 4 volt. We know this one. Okay, so we have all the information here. So this voltage here is in this direction. This one is this direction. This one is in this direction. And this one is in this direction. So if you assume that the clockwise direction is the positive direction, then in this case 24 is positive, 20 is negative, VL is negative, and 4 volt is negative also. If you are moving clockwise direction, then in this case 24 is positive, 20 is negative, VL is negative, 4 volt is negative, equal 0. So it's very clear that VL is also 0 here, because it is 24 will cancel with 4 and 20. 4 and 20 is 24, and so it is negative 24 plus 24 will be 0. So VL is 0. So this one will be 0. This one will be 0. Now let us see here the final values. Final values. Can I just calculate the final value and say that the final values here are 0? No. Why? Because the circuit, this circuit here, after you turn off the switch, you still have a source. So here you cannot say that the voltage across the capacitor is 0 or the current in the inductor is 0. So you need to redraw this circuit again. There it is. You just need to draw it like this. So here is R, which is 5. The inductor is just short circuit. The source is here, positive, negative, 24. And the capacitor is open. You don't have a capacitor. The capacitor will be open circuit. So now what is the current? Is the circuit here? I equal what? I infinity is 0, of course, because you don't have any circuit here. It is open. So I of infinity is 0. Now what is V infinity? What's the voltage across the capacitor? Since you don't have any voltage across this one or any current in the circuit, the voltage will be 24. So the source will be applied directly on the capacitor. So it will be 20. Is this 25? Oh, 25, 24. 24. Be 24. So this is the solution of the last problem in this part of the second order circuit. Next part is talking about source free RLC circuit. See you.